Upwards is a European project with 11 partners from different European nations and also from Argentina, bringing together the expertise in atmospheric simulations, in noise simulations, the wind park, wind turbine expertise and also mathematical expertise to simulate a complete wind park from the beginning to the end.
Upwards in high performance computing in order to understand physical phenomena related to large-scale wind turbines. And we do this in order to optimize the design and be able to predict more accurately future wind park. So we are also adding on the social aspects of wind power.
The atmospheric model WRF has been run at very high resolution, providing the output to other models as the acoustic one. And one of the main achievements has been using this atmospheric model to feed another model developed under this Workpackage 2, which simulates the interaction between the wind flow and the turbine blades.
Workpackage 3 is to develop tools to make the simulation of wind turbines under unsteady wind conditions and to get the dynamics of the wind turbines and the loads that are inside the wind turbines.
The Workpackage 4 was led by VKI and Siemens Industry Software in Belgium, and the main objective was to develop models for noise prediction of wind turbines. The main developments we have done in this Workpackage was first to develop a 2D noise prediction methodology that we can apply first on airfoils, and we validated that on that data available in literature. And then we extended that to rotating machines. And there we mainly used benchmark that we developed in another European project to validate the results.
I'm leading the work package on composite material failure models. Wind turbine blades are huge, lightweight, high-performance structures made from laminated composite materials, and these materials are vulnerable to crack and damage formation when subjected to repeated fatigue loads. And today, there is a lack of methods that with good accuracy can predict fatigue damage in wind turbine blades. In Upwards, we face these challenges in 5 steps. In the first 2 steps, we have developed new fatigue simulation methods that separately may predict intra- and interlaminar fatigue damage in composite materials. And in step 3, we have unified the 2 damage models into a combined model to simulate their interaction and propagation of both damage modes simultaneously. In step 4, we study the effect of complicated fatigue loading spectra to address the complexity of operational loads on wind turbine blades with a lifespan of more than 25 years. And as a final step, the developed fatigue tools are demonstrated on a wind turbine blade substructure of a large trailing edge sandwich panel.
So Workpackage 6 is kind of the glue code which couples all the models together under the hat of, let's say, one huge model, and to let the complete park being executed and analyzed so that we can have a look at the effects, the situations in which each turbine is performed within the park and what will happen, for example, if the wind condition is changing. So in Upwards, we are building up a simulation framework which enables park designer to simulate based on a configuration, so where to put the turbines depending on the shape of the landscape, depending on nearby inhabitants, for example. The park performs best, but under conditions so that, for example, the social acceptance, we can generate data very fast so that we can draw conclusions.
So in Upwards, we understand that the challenges of wind energy are not only technical, they are also social. So this is why in Workpackage 7, we focus on understanding public acceptance. And by doing so, we decided to focus on noise and noise as a key factor. And for that, we in Workpackage 7, we looked into the noise regulation in Europe. And then we also looked at the available data about societal annoyance. This became a very important input for the simulation within Upwards. We also conducted an in-depth study to understand actually how people at the local level understand noise and why they are concerned about it.
In this work package, we have three main objectives: to create awareness, give, and visibility and understanding of the project by creating a website and by being active on social networks, to disseminate technical content and public deliverables to reach a scientific community, to ensure the connection between research and development and industrialization. In this last objective, we try to identify a market and industrial exploitation possibilities for rich acquired knowledge. The challenge for us is to collect technical content from partners and then disseminate it, while adapting it to the target audience we wish to reach.
New wind parks have to be created to bring us green energy, but the question is where to put these, to save the nature, not disturb the inhabitants, but also to bring us the energy power which we really need without creating too much carbon, for example.
So collaboration.
Societal engagement.
Multidisciplinary.
Energy transition.